Now, to put this situation with the ln over quad in perspective, because anytime you got a ln over a quad, ln over an irreducible quadratic, you're going to have a 0, and you're going to have asymptotes to the x-axis. And you'll have the y-intercept, and it's just going to be pretty much like this, depending on where the zeros and y-intercepts are, of course. Let's contrast this with this, which is a linear divided by a quadratic, but it's not what I call the form ln over quad, because the quadratic factors. Okay, the denominator factors into x plus 6 times x minus 2. Form is linear over linear times linear, not ln over quad. And if you just do what we do, we see that we have zeros in the denominator at 2 and negative 6, and those aren't zeros of the function, those are asymptotes. I've been habitually using x's for zeros of the denominator, and what happened to my 6? Okay, and then at negative 9, we have a 0 of the numerator, which gives us a 0 of the whole function, because when you divide 0 by something that isn't 0, you get 0. So the graph has to go through this point, it has to have asymptotes here and here. You check the signs, and you'll find that the sign is negative over here, positive here, negative here, and positive here. We also see that the large x behavior, for the same reason it is here, this still behaves like x over x squared when x is really big. You know, you got a really big divided by a really big times a really big. Okay? So you're going to have a graph comes up. Doesn't come up from large negative. It comes from here, probably dips down a little bit, then goes up through here, and then approaches this asymptote on the positive side. For positive x on the upper half plane. Okay. And then to the right of this asymptote comes up from down here. Now let's go ahead and figure out what the y-intercept is. Well, it's 9 over negative 12, which is negative 3/4. Negative 3/4 here. So it's going to come up from down here. Come around here, come back down here. It's got to be negative for this whole interval. Can't go through the x-axis. So I already knew the y-intercept was going to have to be negative, but I can calculate it, and there it is. Okay. Then on the positive side, it comes down from the asymptote here, and it has to approach the x-axis as an asymptote here. So this situation is a little more complex than this one. This one's actually pretty simple. So you don't necessarily know when you look at the function whether the denominator is going to factor or not. So you don't know whether you're going to have this or this. So you proceed, same steps, Find the zeros of the numerator, find the zeros of the denominator. If you've got zeros, you're going to have to draw segments for the vertical asymptotes. If you don't have zeros, then you've just got the zero. Figure out where your y-intercept is. Your large X behavior, either a linear over quadratic or a linear over linear times linear, which is always going to give you a linear expression here and a quadratic expression here, always does this. Always acts like 1 over x for large X. It's always got to approach the x-axis. Now it might act like negative 1 over x, where the thing is positive in this quadrant, negative in this one. That's okay. If you work out the signs, mark the asymptotes, mark the zeros, take account of everything and follow a very uniform procedure. You get this, or you get this, without much trouble. Also, anytime the degree of the denominator, the largest exponent in the denominator, is greater than the degree of the numerator, you're going to have an asymptote with the x-axis. It might reduce down to 1 over x squared or 1 over x cubed, if it was a linear over cubic or linear over quarter, or linear over product of two quadratics, but it's always going to behave in a way very similar to this. Okay? The only question is which side of the axis the zeros are on, which side of the x-axis the asymptotes are on.